Alright, today I'm going to be lecturing on Chapter 5. Starts on page 267. I did go through some of it last time, but we sort of plowed through it quickly. So, talk a little bit more about list boxes, while loop, plus plus, minus minus operators, the three kinds of loops, while, for, and do while. Then we get into files. This is the stuff we didn't cover last time, so we will today. Files for data storage, open file and save file dialog controls, a little bit about random numbers, and the load event. Alright, now what I've done, and I'll have to, let me save this to the desktop. I have created a couple files for you that have got some information, and I put them in a folder, you know the drill by now, under the class folder in the in class under the 225. There's a couple files in there, but they're just very simple files. I just want to quickly show them to you though. The first one is called Chapter 5 URLs, and it's got information in there on the Listbox class itself. So in other words, it shows all of the properties of the Listbox, and it shows all of the methods of the Listbox, and that's taken right from the Microsoft Developer Network. Second, I'm going to show you, just in case you didn't know this, how you can literally write to a console line in C#. And then the other things that are in here, these are all on random number generation, which we'll get to at the end of the class. Alright, and the other file that's in here has just got some examples, very similar to some of the stuff I showed you the other day, but I'm just trying to kind of emphasize what we're talking about, and hopefully it'll make some sense to you. So, we talked a little bit about list boxes in the past. You know now, or you should know, how to add an item to a list box. Alright, that shouldn't be anything new to you. Remember that when you do come in, and so if I come in here and I start up a new project, I'm not going to even save this because it'll just be a garbage project. But if I come in here and start up something brand new, and I've shown you this before, but if I've got a list box here and I want to fill it up, there's three different ways that I can fill up a list box. The first way is I can come in here and I can click this smart tag that's up on the top, this little arrow that's in the upper right hand corner. I can click there and choose edit items and type in whatever I want to type in. So I can do that if I want to. Now that stuff is in there. Alright? And if I don't want to do that, some people like to fill it up that way. Other people like to come in, make sure the list box is highlighted. Again, we should have changed the names here. So let's suppose that it is going to be a list of names, so we'll just call it list box names. Alright? But I can also come in here and go down towards the bottom. That's in here someplace. Under items, it says collection. If I click on that, I get an ellipsis, and if I click the ellipsis, I get the same thing that I just got from clicking the smart tag. Alright? So I can, again, put in names that way. If I don't want to do it either of those ways, let's say what I want to do is I want to be able to put in names, but I want to be able to put in names, via a button, let's just say. Alright? So, again, I should change that to button, input names. Alright, now when I come in here, I can come in and manually add them this way too. So list box names dot add Jeff. In fact, that's list box names dot items dot add. Alright, and if if I wanted to do that and put in 3 or 4 names this way, I can do it like that too. All right, like that. And you'll notice that when I do that and I run the program, there should be nothing in the list box when we start up. But as soon as I click input, boom, they're there. So that's 3 ways that you can input information. You also know, or hopefully you know by now, that if I come back to that list box, and regardless of how I add the information, if I come back to the list box and I find the sorted property, and I double click it to set it to true, all right, now even though the order in which I'm putting these in, well, of course I'd put them in already in alphabetic order, but let's skew that order. All right, so we've got Sue, Mary, Jeff. Okay, so if I go and run the program again now, you notice that they go in alphabetic order immediately. So if having some semblance of order is important, then you'd want to manually set that sorted property. But again, you probably know this, but I'm just saying this in case you don't. Let's go back to the sorted property. And let's set it back to false. There's nothing to preclude me from coming in here and saying listbox names dot sorted equal true. So I can do it in code too. Virtually every property that you see here in your properties list, you can set it either here in the properties list or you can set it in code. What's the difference? If you set it in the properties list, it's a set it and forget it. If you set it in code, you can set it basically, for instance, if I wanted to, I could just say set this to set sorted to true, but only if there are names in there, for instance. So I can do it programmatically. All right. Now, one of the URLs that I gave you, again, from here, just so you see this, was this one right here. And this, again, as I mentioned to you, this is from, in fact, I've got it right here, Listbox class from Microsoft Developer Network. What's nice about this is notice what they have. So they show you. Those are the constructors. Don't even worry about that. These are all the properties, and it's an explanation of every property. So if you say, well, I'm looking at this, and I have no idea what the heck this property means. Hopefully you've already realized that the way this stuff works is if you come out to a property, so if I come out to, for example, the size here, and I put my mouse on it, usually sooner or later I'll get a little tooltip, but that doesn't always give you a great explanation of what the property is. All right, you get a little thing down here, the size of the control in pixels. Well, that's not bad for that particular control, but sometimes you don't have a clue as to what they mean. So these are all hyperlinked, all right, and it shows you. Then when it gets done with that, and you notice there's a lot of properties, but when you get done with the properties then, sooner or later, all right, there's a thing in there, and I probably just clicked the wrong button, but that also shows you the methods. They're all in there. So if I click on methods, because again, there are a boatload of methods that we never go over, and they're here and they're in alphabetic order. Now the way to become a quote expert unquote on this isn't to look at the documentation and memorize this stuff. Yeah, looking at the documentation is important, but looking at the documentation and realizing it's the old 20-80 rule, learn the 20% of those properties that you'll use 80% of the time. All right? And for the ones that you won't, that you'll use on a very irregular basis, know where to go to find them. All right, so they go through a lot in here. They talk about the count property and the clear property, etc. And again, we've talked about those before. All right. The next thing, and I'm going to take this a little bit out of order from the way they did it in the book, because I'm going to just talk about all 3 of the loops. What I've done here is I've got all of them in here, but I put some space in between there so I'm not cluttering up the screen all the time. So when we go through this, I'm going to go through a few concepts, and most of these concepts we've already talked about. But if you have a question, please stop and ask me. All right? I don't want to just assume that you understand everything I'm talking about here. All right. Again, I oftentimes call my loop control variable LCV, for loop control variable. All right, so this is a while loop. A while loop is a pretest. We talked about this before. All right, so if we did this, if we said while LCV is less than or equal to 0, it's not, since you make the test right here before you go into the body of the loop, if that was your test, it would fail. So you would execute none of this. You would come right down to here. And that should make sense to everybody who's in this room. All right? If it doesn't, then go take some time and take a look at it. All right? But like I said, hopefully that makes sense. So this is a loop control variable. This is an accumulator, which is also discussed in the chapter. All right? So what are we doing in here? Let's go back and set it to 10. Very similar to the example I showed you the other day. This is saying, basically, this is my accumulator. So my accumulator when I start is 0. So as I go through there, I'm going to add 1 to it, and then I'm going to add 2 to it, and then I'm going to add 3 to it, etc. So when I get all done, it'll be equal to 55. All right? And so that's an accumulator. And again, as I mentioned here, this total plus equals LCV is a shortcut for tot equals tot plus LCV. All right? This allows you to write it rather than using a message box, because if I had a message box and I ran this program, I'd get 10 different message boxes. It would say LCV equal 1, then I get another message box that said LCV equals 2, then another one that says LCV equals 3, which is kind of silly. All right, so this literally says print this out to a DOS command line. All right. Now, Denny Wright has taught this class before, and Denny teaches people first how to program using the command line. I don't do that. There's nothing wrong with him doing that. All right. And maybe people are stronger for learning it that way because they're not worried about the GUI. All right. But to me, there's very few times where you're going to do things on a command line. But this would be an example of a time you might want to. So that would write it out literally to a DOS command line. This right here, remember, we've talked about this before. That line that you see right there that's now in blue, LCV++. If it's on a line by itself, I can say plus plus LCV. I can say LCV++. I can say LCV equals LCV plus 1. Or I can say LCV plus equals 1. All 4 of those will add 1 to my loop control variable. The one you use should be the one that makes the most sense to you right now. All right, most people who are professional will not use this one. They will use one of the other 3. All right. So again, this is a pretest. This is literally going to print out on the command line LCV equal 1, LCV equal 2, LCV equal 3, 10 times. All right. And when we get done, when we fall out of this loop, LCV will now be equal to 11 when we fall out of the loop, and tot should be equal to 55, which is 1 plus 2 plus 3, etc. But when you work with a while loop, there's 3 steps. Actually, with any loop, there's 3 steps. The first step is you must initialize your loop control variable. So that's the first step. The second step is you must test your loop control variable. And the third step is you must change your loop control variable. All right, and as long as I change it, I mentioned this to you the other day, if I go minus minus here, I'm going to be in trouble. Because I'm never going to get to 10. I'm going to eventually get into an infinite loop. Now that's all I was going to say. Is there anything about the while loop that doesn't make sense to people? All right, then let's look at the next one. I don't know why that's hanging there, but it is. The do while looks a lot like the while, but whereas the while loop is a pretest, the do loop is a post-test, which means it always runs at least once. So if you want to make sure that your loop always runs at least once, you use a while loop. I'm sorry, a do while loop. You'll notice this is the exact same stuff that we saw before. Setting my loop control variable to 1 and my accumulator to 0. What changes here is instead of the while condition being at the beginning, as it was in a while loop, it's at the end. This is also the only time that you put a semicolon at the end of the line. I've seen people do this, where they write something like this: while x less than or equal to 10. That's not going to do diddly. Right? That's just wrong. Now, when I'm talking about in a regular while loop, that's like saying for x equals 0, x less than or equal to 10, x plus plus, semicolon. No. The only time that you will use a semicolon is with a do while loop, and it goes on the end. So it's the word do And you must, even if there's only one line of code, you must use curly braces here. All right, that's the syntax of the language. Java works the same way. All right, JavaScript works the same way. Most programming languages offer you the three loops: a while loop, a do-while loop, and a for loop. VisualBasic.net actually offers you different versions, and they have like about 8 different loops. But the ones that are used the most often are these 3. All right. So notice too, do this. So what's this going to do? It's going to add 1 to my total. It's going to print it out, then it's going to add 1 to it. Exactly what we'd want it to do. After we do it for the 10th time, all right, and we say LCV equal 10, we add 1 to it, which means it's 11. We make the test. Now the test fails because it's not less than or equal to 10. So boom. All right, we get out. But again, same kind of thing. Initialize, test, and change the value of your loop control variable. Any questions on the do while? And the last one's the for loop. Now, notice we've got 3 lines in here. We've got 3 lines in here. And with the for loop, we only have 2 lines. That's because with the for loop, you do your initialization, your test, and you're changing all on the same line of code. At least you can if you want to. All right? So you typically end up writing a little bit less code with a for loop than you do with a while loop or a do while loop. The for loop is a counting loop. You have to know exactly how many times you're going to go through it. Why does that matter? Well, later on in the chapter here, we're going to talk about files. What if you had a file of records? All right, you work for an insurance company, you got a file of different clients, and you don't know how many records there are in there. All right, you can't use a for loop then, but you can use a while or a do while, because what you check with a while doesn't have to be this. It can be something like while not end of file, but you can't do something like that with a for loop. All right, so again, a for loop is a counting loop. It's also a pretest. So if we said it equals 1 while it's less than or equal to -10, that'll never run. But I can do this. I can say while it's equal to 10, while it's less than or equal to 1, but then I could say minus minus. That's going to now print out LCV equal 10, LCV equal 9, LCV equal 8, but it'll still add up 10 plus 9 plus 8 plus 7 all the way down to 1. So I'll still get 55. So you can go backwards. Okay? But then you've got to adjust your conditions here. The other thing I wanted to mention to you before I jump back into the book, which I'll do in just a second, is this stuff. And we looked at this before. I put this out there, and hopefully this makes it easier to understand for you, not harder. And if it makes it harder, I'm sorry. The thing about using plus plus and minus minus, they'll only add 1 or subtract 1. You can't use plus plus and minus minus with anything other than adding, incrementing by 1, or decrementing by 1. All right? So if I start out and I've got this, x equals 3, y equals 0, and I type in this, y equals plus plus x. Since the plus is at the beginning, it's called the pre-increment operator. That means add 1 to x, so x is now 4, and then take 4, which is the value, and assign it to y. In other words, they're both equal to 4. On the other hand, if I say instead of plus plus x, if I instead say x plus plus, that's the post-increment operator. All right? So that says, and I guess that should have been what? That should have been 4, and that should have been 3. All right. This one here says take whatever was at x, which is 3, assign it to y, so y is 3, then add 1 to x. All right, and minus minus works the same way. This is the pre-decrement. So take x, which was 3, subtract 1 from it. Boy, I guess I can't do math. So x is going to be equal to 2. All right, and then do the same thing to y. Whereas over here, I take x, which was 3, and assign that to y, then subtract 1. So x is going to be equal to 2 and y is going to be equal to 3. Now, I went over those, butchered them a little bit, but using plus plus, minus minus, and the other ones that we talked a little bit about but haven't really seen that much, those being the plus equals, the minus equals, the times equals, the divide equals, and the modulo equals. Because all of those are supported in this language. The best way to learn these is to write yourself up a real simple little C# program and do something like this, and then start doing these different things and printing out the result. That's how you learn. Just experiment with it. All right? There are plenty of examples in the book as well. So the book here went over the while loop, and I just did that. Talks about it being a pretest, talks about your loop control variable, gives you a program that actually shows you bank interest. Nice program, absolutely nothing wrong with it. Then he talks about infinite loops, and I already mentioned those to you, but if you look right here, that's a good example of an infinite loop. Count is equal to 1. While it's less than or equal to 5, display hello. You're never changing the value of count. Remember, there's 3 things that you have to do for a loop. You have to initialize your loop control variable, test your loop control variable, and change your loop control variable. We're never changing it. So that's just going to keep printing out hello, 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 hello. Boom. Eventually you'll go into an infinite loop. All right, the plus, plus, and minus, minus, I just went over with you. So again, if you like their examples better than mine, then go for it. Great. The for loop, we just went over. The for loop is a pretest loop, like the while loop, and the do while loop is a post-test. All right. I went over some examples of some of this stuff last time. You know, if you remember that program that we went and looked at the other day. All right. And I put that out there. That was that Fun with Loops program, that you can manipulate the loop control variable if you want to. There's a lot of different things that you can do with it. You can count backwards. We talked about that before. I just showed you an example of that. I mentioned this the other day. I'm saying it again. Avoid modifying the counter variable, which is what I call LCV, or the loop control variable. The only place that you should modify the loop control variable, for example, in this for loop, is right here. You should never do this. If you're doing that, you shouldn't be using a loop. All right? Because you're doing things against the grain, so to speak, of the way you should be doing them. All right, then he goes through this thing that has got miles per hour, where he goes between kilometers per hour and miles per hour. Do while we've talked about already. Which brings us to, I jumped right past it, talking about files. So I'm up on page 291, talking about files. All right? And to put it in a nutshell, what the author says here is basically everything we've done thus far. Think about your BMI program. All right? That every single time you put in a height, you put in a weight, you hit the button, and now you've got it set up so you get the height and the weight. You're sure they're within range. You get the BMI that you calculate. You get the weight status that you calculate. But as soon as you put in another one, you lost the original one. So, for example, if I wanted to do this where I was putting in the heights and weights, if I worked for a doctor's office of 100 people, maybe I'd also have names in there, but names, you know, first name, last name, and height and weight. All right, right now there's no way for me to save that. So the author says one way that you can save that stuff is to use a file. All right? And as he says in here, when the program needs to save data for later use, it writes it to a file. That's one way you can do it. And really, a database is just kind of another way of handling a file. All right. So he says that there's a lot of different things that use files. Okay. One thing that you have to realize, and you have to be kind of cognizant of from the start, is when you write stuff to a file, that's cool as long as you're writing text to a file. Because if you're just writing text to a file, so in other words, let's imagine with the BMI that I made a change to it, so I put a little more stuff in it. It had a first name and a last name and a height and a weight. Okay, so I put in the first name, put in the last name, I put in the height, I put in the weight, and boom, it spits out the BMI and their status. Okay, but I want to save that. So I can either grab that information. I mean, I don't want to maybe enter in 100 different patients. It would be nice if I had 100 different people with their names, their heights, and their weights, and I could plug those into the program and have the program just calculate for me the BMI and the status. You can do that. So you can use files to read information, to write information, or both, where you're both reading and writing. If you open up a file with read permission, you can only read to it. If you attempt to write to a file that you've opened up with read permission only, you'll get an error. You can open up a file with write permission only, and if you attempt to read that file, you'll get an error. So a lot of times you open up a file in what's typically called like append type of permission, which means that you're opening it up and you can read it and you can write to it also. And that's what they talk about in here. All right, so they show some examples. And again, you oftentimes see stuff like this. He says writing files on a disk. Really, is that how it looks? And I mean, in the bottom line, no, because what's the only thing you can write to a computer? Zeros and ones. But to show Cindy Chandler 7451Z in 1865 in zeros and ones probably wouldn't make sense to most of us. All right, so we envision it that way. So as it says, the process of retrieving data from a file is called reading it, and typically you use an input file. So if that information is there, I could bring this up. Why would I bring that up? Well, maybe I needed it in a program. Maybe I needed to change it. So if I bring that up and Cindy Chandler has gotten married and is now Cindy something else, let's say, I wouldn't want to bring that up in read permission. I'd want to bring that up in either, basically probably in append type of permission. So they mention here, it says there's 3 steps that must be taken when you're using a file in a program. You've got to open it, do your processing, and close it. If for some reason you forget to close the file, when the program ends, the file is closed. But especially if you've got a file with hundreds or thousands or hundreds of thousands of names in it, it's important that you close the file as soon as you're done using it. It hasn't happened yet, but usually as the weather gets better and spring comes, we get a thunderstorm around here. And there'll be a time when you're working and boom, there'll be a clap of thunder and everybody's machine will go off for a second and go on again. If that happens and you're working with a file that's got hundreds of thousands of names in it and you open that file and didn't close it, there's a chance that file could have been corrupted. It may or may not have. I'll always remember this, that this is the first real true programming class that I took. All right, it was a Fortran programming class. It must have been about early 80s. And it was at the University of Wisconsin Marathon County Extension. We used Macs, the old one-piece Macs that had a monitor on them that was about just a few inches. And we had to work on this program that he gave us for our final. And it was a really hard program. I'm not even going to go into it with you. But we were working, and the weather was terrible. They kept the lab open until midnight that night. This wasn't the time when you had your own machine, etc. You didn't have any friggin' internet. You had nothing. So we're all sitting there, and we're working away, and about 11:45, we got a crack of lightning. And everybody's machine went down and went back up again. And you heard there was a woman in there just dropped the biggest, loudest F-bomb I've ever heard. She hadn't saved once. She'd been working as long as I was which was at least 4 hours plus. And the lab assistant looked at her and goes, "Did you save?" She goes, "No." And he goes, "Your problem, not mine." Just spun his chair around. Now it's a lot nicer because with most software, there's auto-save on it. All right, would have helped her. But it happened to me once, too. I was working on my master's thesis. The same kind of thing happened. I was working at home. Woke my wife up with an F-bomb. About 3 in the morning. She said, "What's wrong?" I said, "Nothing, just go back to sleep." A text file is one you can read. Literally. So it's one, look at it this way. If I can open it up in Word, it's some kind of a text file. All right? And you probably have already seen this. But if I come in, for example, and I try to take this PDF, and I try to edit it with Notepad, it doesn't look very good, because that's a binary file. That's a file that's not meant to be read in this format. All right? audio files, video files, etc. Any non-text files, those are binary data files. And he talked about that a little bit in here. All right. When you access a file, there's two ways of accessing it. You can do it sequentially or you can do it randomly. All right. And I've given this, and it's funny because every semester as we go on and the students get younger and younger, and I get older and older, but when I come back and give you this analogy, sometimes people look at me like I don't know what that is. But back in the days when we had cassette tapes, and you wanted to listen to song number 8 on your cassette tape, all right, and you were on song 1, you either had to listen to the first 7 or fast forward. Now with CDs and the like and everything else, you can just typically press a button. Well, working with cassette tapes is sequential access. You got to read every record. Working with a thing like a CD, all right, that's random access where you can jump right to the record you want to jump to. Plus, when you work with random access files, you can do what's called updating in place. So if I've got 1,000 records and I need to fix record 500, if it's sequential, what I have to do is I have to write the first 499 records to a new file. Then I have to go and bring up record 500, fix it, write that to the file, and then write the last 500 records to a new file. All right, but if I'm using random access, I jump right to the record I want to change it, and boom. So you say, well, geez, why don't we use random access for everything? It can waste space. When you use random access, every record in the file has to be exactly the same size. So if you've got somebody with a huge name and somebody with a really small name, they have to take up the same amount of space because the computer has to be able to figure out exactly how to jump from one record to the other. All right? And a lot of programs, for example, the payroll program here is sequential. There's no need to be able to have to jump around from record to record, etc. All right. Files on a disk, as it says, they're known by file names and they're known by file extensions. It says in order to work with a file on the computer's disk, you must create a file object in memory. And people hear that and they get a little bit, ugh. You've been working with objects all semester. You've been working with form objects, button objects, text box objects, label objects. This is an object-oriented programming language, so you've been working with objects. And in much the same way, when you work with files, you have to work with a file object. As it says, it's an object that's associated with a file. All right, you say that it references the file. Now, what does that mean? Well, you're able to do stuff like this. Okay? And if you look at the lines of code here, and he does a really nice job underneath of explaining it. I don't want to read his stuff to you. But here you're creating basically a file object. It's of type StreamWriter. Guess what? There's a type StreamReader if you just want to read it. But here we want to write to the file. And what we're saying in this line is, okay, I've got a file on the system that's called courses.txt, but I want to refer to it in my program as output file. And then what I'm doing here is I'm writing 4 lines to that file. So that'll write intro to computer science, hit the enter key, write English composition, hit the enter key, write calculus 1, hit the enter key, and put in music appreciation. Then when I do this, it'll make sure that file is closed. That's pretty much the same thing that they say right here. All right. So it's a little hinky, but it's just the way that it has to be done. So you bring it up afterwards, and this is what you get. And again, he's got several examples in here. He's got a couple right examples. Then he talks about, you know what? What if you try to do this and it doesn't work? All right. Why wouldn't it work? Well, for example, and maybe you've already run across this. I've mentioned it before. If somehow you tried to put in this code, all that code that we see right there, but you were trying to write to the P drive, you as students don't have access to write to the P drive. It would fail. So a lot of times when you're going and you're trying to do this, you end up putting the stuff in try-catch blocks. And notice they're just using a generic exception here, but there is an I/O exception that you can have too, an input-output exception. And there are file exceptions, etc. So I don't know why he does this, but he does this in all of his books. He's got this simple thing right here that has a label and a text box. And it says write name. And every time you put a name in there and you click write name, it writes a name to the file. And it, there's no validation in here. So if you said the name, you just hit enter, it would say fine. If you put 567, it would think that's a name. All right, so there's nothing in it. But what he shows you in here, first of all, that's new. Using system.io, you'll have to add that. Literally, you'll have to type that in if you're going to be using file handling. Then he comes through and he does his try block where he sets up his stream writer, all right, attempts to associate that with a file, and every time he comes through there, attempts to write out that line of text to the file. Okay? And if you run all this stuff, it's going to create, here he just puts 10 numbers in it, but that you can see the idea. All right? So that's opening it up in write permission. You can also open it up in read permission, or as it says, you can open it up in append permission. By default, when you append to a file, you put stuff on the end of it. All right, so notice it's append text. Now, do you have to worry about these? I wanted to mention them to you for completeness. I'm not giving you an assignment that you have to work with files. At the end of the semester, we will do a program as a class where we work with a database. All right, but as far as files, we don't have to worry about it. But I wanted you to at least see the stuff that's in here. All right, so here they talk about using, just like there was a stream writer to write, there's a stream reader to read. And rather than using a write line, you use a read line. Again, if you bring up a file with read permission, you can't write to it. And he goes through the same file that he's already created, then again explains line by line what's happening in here. Now there's a lot of stuff in here, but just so you know it, when you open up a file for read permission, I'm just giving this to you in a nutshell. This thing that's right here is called a file pointer. And by default, when you open it up, it points to the beginning of the file. That's all they're telling you. Okay? On the other hand, if you open up a file with append permission, which means you can either read to it or write to it, typically what it does is it takes that file pointer and it puts it at the end of the file because it thinks that you might want to write. Okay? And you literally can reposition this pointer if you want to do so. He talks about it. There's a seek method that you can use, and he talks about it a little bit in here. Reading a file with a loop and detecting the end of the file, this is what I mentioned to you before, that you can do this. That kind of thing would work with a while loop or with a do while loop. You can't do that with a for loop. The for loop, whatever your condition is to end the loop, must be something that the computer can look at and know exactly how many iterations it's going through. Again, the for loop is typically referred to as a counting loop. All right. So he has you, brings up this list box, and when you click Get Countries, it brings up all the countries. Okay? So it reads them in. Calculating the running total, I've already shown you this. That was that accumulator that we talked about before. So this should make sense to you when you look at this. This is page 314 in the book. Total sales. So if I put 100 in here and I click read sales and calculate total, so if I click that, I keep adding to a total. So if I put all these in, when I get done, the final total is going to be 1,000 plus 1,200 plus 1,800, etc. It'll be all those. And that's what he's saying in here. So when you get all done, it'll show you the total sales. So in this case, that total, okay, that total sales, that's your accumulator. All right, let's jump into talking about these. The open file dialog and the save file dialog controls. And I'm going to jump back into the code here, all right, and I'm going to grab one of those. If I remember where they are. There they are, under dialogues. All right, so for instance, and just so you see this, this is what's called an invisible control. Watch, I'll grab an open dialog. I can throw it anywhere. And you don't see it because it goes down here. All right, this has got different names. All right. it's called the, I don't know, like the rack or something like that. But this is a control that you literally don't see on the screen. It's an invisible control. All right. And literally, let's go back because that's how you add one. So I can add that. I can add a color dialog. I can add a font dialog. Oops. I can add an open file. I already got one of those. I can add a save file dialog, and you see how they get put in there. All right, and they all have very similar. They're not identical, but they have very similar types of properties in here. So the author says he starts with the open file dialog, and he says it shows you this standard type of file dialog. By default, which means unless told otherwise, it's going to show you everything. But you can put what are called filters in here. So if I want to filter this so that all that I show are text files, I can set it up so that the only thing I'm showing in here are .txt files, if for some reason I want to do that. So I just showed you how to add it. You can also double click on it, that's fine. Okay, they say it's called the component tray down on the bottom. So this thing down here, that's the term Gaddis at least uses, is the component tray. They're also known as being invisible controls. All right. Then to use it, as it says in here, it's the name of your dialog .show dialog. That's it. That's all you have to put in. All right. And when you put that in, it's going to bring up something. After you put that in, it says, okay. Well, I thought he showed one, but I guess he did earlier. All right. So let's look at the code he's got in here. This says if open show dialog box equal dialog result OK, all right, open the selected file. Now, you might look at that and go, wait a minute, that's not what you told. Yes, it is. This is going to show the dialog box. And it'll have a button in there basically that says OK. And if you click that button, it's going to go in and do this. Exactly what you tell it to do. Just like there is an open dialog, there's going to be a save in just a minute. Now notice again, you can come in here. You can tell it what the initial directory is. So in other words, I'm saying here I want it to go to the C drive and read everything out of the data directory. So you can get as granular with this stuff as you want to get and tell it exactly what you want. All right, he doesn't go into a lot of depth and breadth of coverage on it, but you can, even more than what he shows here. The save works in a similar way, but again, it brings up a save dialog box. All right. Random numbers, again, I showed you this earlier, but I want you to see this, that a bunch of these things that I put up there, so I've already shown you that, and you can look at that on your own. This was a thing from Stack Overflow, where the guy in here said that literally if you write something like this, those of you who are, especially who are gamers or have a desire to do something game-oriented, this is kind of a cool line of code up there in the blue, because what it's saying is, I want to be able to create a new random number, and down here, for instance, I could put, instead of -1 and 1, I could put, for example, in there something like 1 and 1,000 to give me a random number between 1 and 1,000. But what this does is it says, the key thing is right there. What that does is what's referred to as seeding the rand. It looks at the current system time, and it says, oh, use that as a baseline value for giving me a random number. You might say, big deal. If you don't do what's called seed the rand like they show it here, your random numbers, you might get 50 or 60 straight random numbers. Boom. Then the pattern typically starts to repeat after that. But if you seed the rand like this, ideally, your pattern will never repeat. It's kind of like using pi, where supposedly pi doesn't have any repeat, no matter how far out you go, there's no pattern to it. So we've got that from Stack Overflow. Here's the actual thing from a play. I never heard of this site before, but it's called .NET Pearls. And it's kind of nice because it's written in a very straightforward, I'm not going to say simplistic, but a really intuitive manner. That wasn't bad. And this was the actual random class that you can get. And as always, they'll show you some examples of it too. And notice when you look in here, sometimes what you'll find when you look at the stuff in here is there might be something available in VB that's not available in C# or vice versa. All right, just so you know that. So He talks about random numbers are used for a lot of reasons. The simplest way to create it is just basically to do it like this. Notice what it says. The .NET framework provides a class named random. You can use in C# to generate random numbers. That creates the object. He explains in detail here on 323 exactly what's going on. So the word random right here, that's a class. That's the name of your variable. That's saying I want a new random class, so I want you to instantiate it and call it rand. Again, he explains all that right here. Then what you can do is you can ask for this. Now, if you look at this example that he shows right here, so if you do this, then you do this, that will give you a random number, and that random number will be between 0 and 2 billion something. All right, so unless you've got really a strong reason to use something like that, you probably won't want a range that's that big. For instance, the example that you're going to do for your homework is the guessing game, so you should be generating a random number between 1 and 100. All right. So notice here it says this one will generate a random number between 0 and 99. So that line of code that you see right there, that line. So in other words, if I come up and let's just go to the beginning here and do this, all right. So I'm assuming I already did the random number equals new random. All right, so I'm already done this. Now, if I do this, this is going to be give me a random number between 0 and 99. So what do I do? Now that gives me a random number between 1 and 100. Does that make sense? All right, why am I showing you that? Because that's what you're asked to do in your programming assignment. All right, so you can grab the next integer, the next double. They've got a program here that simulates coin tosses. So you can run it a bunch of times and it'll show you heads or tails. He talks some more about seeding the rand here on page 328. And then finally he ends the chapter here starting on 328 with the load event. Notice what it says. When an application form loads into memory, an event known as load takes place. You can write an event handler for this, which will execute just before the form is displayed. The key thing there is this. You may or may not remember this, but a couple times when I've shown you things, I haven't put code in the form load event, I put it in the form activated event. If you put it in the load event, the form is loading into memory, but it's not there yet. If you put it into the activated event, it's now loaded into memory, all right, and it's available to you. All right, sometimes people put code in the load event and there's like, it didn't fire. Yes, it did, you just didn't see it. So he talks a little bit about that. He tells you how to create a load event handler. All right, nothing really much to it, to be honest with you. And that's it for the chapter. So before we break, and after the break, if you leave, then you're leaving. All right, but I want to make sure that you all at least hear this. This is all stuff that we've talked about previously, so I don't want anybody to say, well, geez, I didn't know that. All right. First of all, in your homework folder for the class, I've got executables. This is the program we did the other day, that's Celsius to Fahrenheit. That's the one that we looked at the other day, and my random number one that I did. All right. So you can see how it plays. Okay, it took me 5 guesses, that kind of an idea. I want you to do something like this. If yours doesn't look just like this, that's okay. Some of you for your BMI program were writing, you had instructions in there and stuff, and that's fine. I'm looking for the functionality to make sure the program works. Some of you have been making everything that you do in gray. I don't care. If you want a gray background, gray controls, and black text, that's totally fine. I don't really care. All right, but that stuff is out there. And the other thing I want to tell you is, okay, here's the homework page. All right, so right now, most everyone in here has finished the first assignment that I asked you to do, which was the one from Chapter 3, the original BMI, all right, and the tip tax total, okay? I'm planning on grading stuff on Friday. So if for some reason you don't have the enhanced BMI done or the distance converter, you know, Friday morning usually is when I sit at home and grade. Right, but that's probably what I'll be doing on Friday morning. So if you get them in by then, that's fine. All right. The next ones that we're doing, now they're officially assigned. So that's Wednesday, '25, 2015. And 2 weeks from today, I believe, is the 11th. Yes, it is. So you will have lab all next week to work on this. All right, and then when we come back from the break, just so you know what we'll be doing, when we come back, we'll be going into Chapter 6. In Chapter 6, what we do is we're going to end up writing our own routines. Okay, and that's what Chapter 6 is about. Okay, and you will be actually creating your own game for that. And it's open-ended as far as how you do it. We'll do this one as a class. Then in Chapter 7, we're going to work on arrays. All right, and it says assigned. We will do something as a class, but you won't have to turn that in. Chapter 8, I'm assigning nothing. Okay? The last couple weeks of class, what I want to do is go through this stuff. Because this right here really shows you how to do classes in C#. All right? And some of you, most of you in here are also in the Java class, so there'll be a lot of review for you. But for those of you who are not in the Java class, all right, it'll be at least somewhat new, both in Chapter 9 and Chapter 10. In Chapter 11, we'll actually go through an example of databases. So you'll see how to hook up to a database and do a few other things. But notice, nothing is going to be assigned from, so the last homework you're going to have is going to be based off of Chapter 7. So when we get back from the break, all right, we're going to go through Chapter 6 and Chapter 7. Those will be the last, so we'll do 6, lab, 7, lab. Then I'll probably give you a week of lab, all right, or we'll do 8, we'll have a lab week even though there's nothing assigned. Then whatever time is left, I'm going to spend up to a week on each of those programs. Does that make sense? So I've just updated that on here. I'll have to copy that over to Blackboard. I have been looking to see what people have done, and if you are in this class, and you've turned in nothing, by a week from tomorrow, I have to do midterm grades. So if you've turned in absolutely nothing, you get an F, or a U for your midterm grade. There's no ifs, ands, or buts about it. There's nothing I can do about that. All right, I'm done. I'm going to go upstairs, and the only thing I'm going to ask of you is if you didn't do it the other day, is, again, that you go out to the folder here that says Syllabus Course Evaluation. You open up the course eval. It looks real ugly when you open it up. A couple of you have asked me about this. All right, so it might look really ugly when you do open it up. And if it does, well, hopefully it'll open up. If that happens, just hit the escape key. So if it looks really huge on your screen, hit the escape key and then it'll be fine. All right, and you're not going to be able to write to this because it's on the P drive. So you can save it to your virtual desktop. Remember, you can leave that stuff out there. I can't see your virtual desktop. I don't want to see your virtual desktop. Any questions on anything we went over or on the homework? So again, rest of the period today is lab. So you've got 5 hours of lab. And if you have a clue, you might even be able to finish the program that you have to do the guessing game today.